with AlgoKit 2 and most recently with AlgoKit 3, where we were insistent on bringing semantically and syntactically regular languages to Algorand. And what I mean by that is it's not Python-like, it's actual Python. Same rules, same words, same syntax, same way of doing things. It's not TypeScript-like, it's actual TypeScript. And again, same rules, same language, same syntax, same way of writing code. And so what does this mean? Well, it means that businesses out there can bring their products from an idea in a guy's head or a girl's head, a startup idea, all the way to production really fast, really cheap. And when they've launched their app, like Lofty have, maintenance of those contracts won't be really expensive because you don't need to hire a Solidity developer or a Move developer for SUI or a Solana, someone who specializes in Rust. Okay, you can hire a Python developer or a TypeScript developer, which are some of the most common and easiest languages to understand and to write. So it doesn't cost a ton to hire developers for them, and then you can build your app using those tools.
First of all, thanks for taking the time to speak with me today. Really excited to learn more about how Algorand has developed since 2023, over 2024 and moving in 2025. And for the first question, I would like to touch on real-world assets. And I want to ask if you can elaborate on Algorand's recent growth in the RWA sector, especially with the role of platforms like Lofty in driving total value locked.
Yeah, sure. So, by the way, great to talk to you again, Andrew. It's wonderful for us to have the opportunity to speak with your listeners. And I think it's really important as well to speak with folks who are involved in different ecosystems because we're trying to avoid the echo chamber that you sometimes see in cryptocurrencies where you do interviews with the same people all the time and talk to the same people all the time. And that's no good, right? You need to be able to spread the message amongst a more diverse group of folks and users. So yeah, I'm of course the CTO at the Algorand Foundation, so most of my work tends to be on the technical side of the business, and that's like driving everything from DevRel to product and engineering, that type of stuff. And so I don't spend a ton of time in the community, but of course I'm someone who does enjoy using Algorand and some of our real world asset products are really incredible. And so I guess someone like Mark, our CMO, or Min, who is our executive vice president of ecosystem, would speak better to the RWA companies and startups within the ecosystem because they spend more time looking at them. But I can certainly speak to some of the rising stars and also maybe talk a little bit about why I think Algorand is so well suited technically to RWAs. And maybe I'll start with the latter just to kind of set the scene. So on most blockchain platforms, applications are implemented by writing smart contracts. And smart contracts are like little apps, right? They're little self-contained apps. I guess the reason they're called smart contracts is that typically their role is to agree the flow of money or information. And so it's usually a contract, if you like, between two users. Algorand, though, doesn't use smart contracts in order to represent real world assets. You don't have to write code in order to mint an RWA on Algorand. And that's one of the most powerful features of it. On Algorand, you can represent a real world asset by minting a native token, but that token can be minted in a declarative fashion. And what I mean by that is you can essentially define upfront the number of tokens, their metadata, like what their reason for being is, what their name is, and what the rules are around them, i.e., can they be frozen? Can they be clawed back? Do they have any administrative configuration? And you simply specify this in kind of a list of entries and you post it to the blockchain. And once you do that, the blockchain reads that request for minting an asset and then mints the tokens for you and gives you control over those tokens, which you can then bind to real world assets that are out there. And so
Not using a smart contract.
without using a smart contract, exactly. Now, you can move these tokens into contracts. You can send, Algorand native tokens into a contract, have some logic that runs. It's not that you can't use smart contracts, you can, but I think what's really powerful is you don't need to in order to just mint an RWA. And so the idea of creating RWA assets represented by tokens, or the tokenization of RWA assets, um, the idea of moving them, the ownership on them, whether you can freeze them or claw them back, all of that stuff is done without writing a single line of code. So no code assets, and that's I think why Algorand is very accessible to businesses that don't come from a blockchain background or maybe are very familiar with blockchain, but they have heard of this notion, of course, of fractionalizing or tokenizing assets, real world assets or otherwise. And so it's a very kind of low or a very gentle learning curve. It's not steep. And so that's really powerful. And maybe one other thing to add, when you mint these tokens that represent the assets, you can do atomic transfers with them as a native primitive. And so maybe I'll describe that very briefly. Regularly with blockchains, we want to do a transaction which is a two-way flow of assets. So for example, maybe someone buys a token that represents a ticket and someone pays, a dollar stable coin for that ticket, and they want to do an instantaneous swap directly so that they both exchange tokens, and they want to eliminate the risk of, say, one person in the deal not sending their token over. And so as part of kind of a fundamental primitive within Algorand, we have this notion of atomic transfers, and this basically says that you can specify a group of transactions and say that they all happen or none of them happen. And this is very powerful because it means that I don't have to trust you. I don't have to send my token to you, okay, which is the ticket, and then wait for you to send the dollars to me, or vice versa. You don't have to send the dollars to me and then wait for me to transfer the token to you. We can agree we'll put these transactions in a group, and they either both go through or neither go through. And so, in summary, from a technical point of view, which is, I guess, the area I can speak best to, um, the ability to have declarative assets without having to write code or maintain code, the ability to do fundamental things like atomic transfers, where you can ensure that transactions go through in a way that you can trust. These types of things make it really attractive to tokenize real world assets on platforms like Algorand. And you're right, of course. Probably the crown jewel of RWA tokenization on Algorand is Lofty, and this is a firm that has I guess, pioneered on Algorand the idea of tokenizing real estate, i.e., homes, buildings, houses, that kind of thing. And there are some hugely valuable properties that have now gone up there.
Yeah,
It's not,
I
it's not
love
just, yeah, yeah,
it.
yeah. So it's not just like, some creaky shed in the middle
There's
of
choice. There's actually
right,
choice.
yeah.
Yeah.
Yeah, there's some serious buildings that have gone up. I think some quite historical buildings as well. And so it's very, very cool. And when you combine that with the technologies I described and the instant finality on Algorand and the quick block times, it's a very attractive platform. There's also a number of other platform, startups that are pushing forward in tokenization. We've got tokenization of precious metals. We have tokenization of plane tickets and other assets like that. So there's a number of different things that are ongoing, including crops and other things like that. But I think Lofty with the tokenization of property is something that people can really, I guess, see the value proposition of very simply.
So two things.
Sure.
Um, what is the benefit of not entering into a smart contract? And the second one is Lofty as a service. So what it's offering is basically people can go and buy a piece of this particular property, which is going to give them a rental yield of 16% because they know they're seeing it on the site.
Yeah.
Um, so is it or is all Lofty is okay, I like this property, I'm gonna buy 1,000 euro worth and I'm gonna get 16% of 16% rental on that 1,000 yield as yield. Is that this is that what Lofty is?
Yeah. So I mean, I guess in the simplest term, what Lofty is trying to do is give people exposure to an asset class, which maybe they wouldn't typically be able to have exposure to. Like as an example, if I wanted to be able to, I mean, I own one home. Actually, I don't even own it. I've got a mortgage on it, but I own a small home in Ireland, and you know, it was I was able to buy it with my wife because we both had good jobs, but we still had to take a mortgage, and it's only a modest home. It's worth, you know, a couple $100,000. It's not worth millions of dollars or anything like that. And so what's interesting, I think, there is that there's a lot of people who maybe are not in stable relationships with where there's two people working and have a good job, and so they may not have the income flow that's required in order to purchase a house. And even in more extreme situations where people maybe have less well-paying jobs, they have no ability maybe to ever get on the property ladder. And then if you take it even one step further and you forget about regular homes that I think most people can sometimes achieve, um, if you wanted to say invest in serious real estate, like a major building in Manhattan or in London or in some other major city, I think the biggest value proposition of things like Lofty is that they provide or democratize access to the asset class that is real estate to the every person. And so you can have, you know, essentially a very small spending power, but still get exposure to the appreciation of assets like real estate. And I think maybe an even more interesting thing, and this is not my idea. This came from I was at Satoshi Roundtable, which is a gathering of crypto, you know, industry folks, industry participants, plus some kind of like OG crypto people. And I was sitting chatting with a really interesting lawyer and a crypto kind of lawyer, and he said to me, the coolest piece for the future of RWA tokenization around real estate is the idea of getting those tokens to secondary markets. Okay,
Mm.
so like right now with Lofty, you on board with Lofty, you KYC with Lofty, they know who you are, you know who they are, you fund, you know, your account with Lofty, and then they can expose you to tokenized versions of real estate. Very cool. But there's a lot, of course, I appreciate, by the way, there's legal complexity, there's regulation, different countries, different jurisdictions. It's not just trivial to do this. But if we can move to a place with more regulatory certainty, and indeed, you know, with the proper frameworks that are required to protect people, because you don't want to buy a home and then find out that the tokens are worthless, kind of thing. But if we can move to a place where we have those structures in place, um, how wonderful would it be to be able to tokenize your own home or percentage of it, or tokenize property that you own, and allow that not just to be sold to, say, one participant one hop away, but allow it to be traded or used as liquidity in other contexts, for loans or insurance and many other contexts. And so that's where I think the real power of tokenization comes, not just maybe exposing yourself if you don't have much money to an asset class that you wouldn't be able to afford the whole of, but rather where you can actually start building derivatives and other secondary markets around these things. And the example that came up at Satoshi Roundtable was, you know, an index. Maybe you could buy California, you could long California and short New York, right? Or you could, um, you know, have an index predicated on the value of homes, maybe across a country or other kind of things like that. And I think that that's a really powerful idea.
It is a powerful idea, definitely. So when you talk about regulatory certainty, are you looking mainly for clarity on stable coins?
Well, yeah, and again, I clarify as I did when I mentioned that I'm probably not the best person to speak on RWAs. I'm also not on the legal side of crypto, but I do spend a lot of time around smart people who are on the legal side of crypto, and so I think it comes in a number of different things from what I've heard. I think it's clarity around stable coins, MiCA, other things. But by the way, there's Europe, there's the US, and there's different
Exactly.
regs, different rules, but like broadly, it's the same themes. Are we okay to issue these stable coins? Are these stable coins compliant with the law? Can they be used in contexts where you are directly purchasing an asset which traditionally will be purchased with fiat? The difference between, say, a stable coin and an electronic money token, for example, Euro D on Algorand. I initially thought it was just a stable coin, but actually it's not. It's a totally different classification. It's actual euro, you know, and so the Central Bank of Europe, sorry, the European Central Bank and the central banks around Europe, particularly the one where it's issued in the Netherlands, they recognize Euro D as part of the European monetary euro supply.
Which
And
is big,
so,
no?
yeah, it's really cool.
Big. It's a good
It's
thing.
really cool. So it's not just like an abstraction, like a peg, like the dollar circle coin, sorry, the circle dollar token or the tether dollar token, where it's just like an IOU. Rather, it's actual euro, and the European Central Bank is like, yeah, that's part of the euro supply. And so, we just need to get to a place where this stuff is better defined so people know that they're not making mistakes, that they're not going to end up in hot water. And indeed, for as I mentioned earlier, the idea of secondary markets or derivatives on RWAs, we just need to get, I guess, to a place where there's consumer protection so that you can feel confident when you're buying maybe a token of Rockefeller Plaza or something like that from a secondary market, that if you do the right checks and you check the cryptographic attestation on this token and you can see, yeah, it was issued by the holder of that building, that it doesn't matter whether you buy it on Tinyman or Lofty or some small exchange that you've never heard of before, because you'll be able to assert its validity.
So it's basically infiltrating the traditional markets.
Right, and and
Okay.
and I think as well, um, I know tokenization, maybe the idea has been around since for a long time. I remember working in Consensus in 2017, and we were working with money market funds that like the idea of tokenization of dark liquidity and various liquidity pools on Ethereum. And so, this idea has been around for like 9, 10 years more, right? But I think now we're seeing it actually play out. Sometimes, you can talk a lot about this stuff, but there's rough edges. And a bit like AI, like the AI was around 15 years ago, right? I mean, convolutional neural networks, recurrent neural networks, speech analysis, pattern analysis. We had these things, but you reach a threshold by which it starts becoming cool and useful and getting kind of more mainstream and productionized. And I think we're getting to that point now with tokenization. We're getting to a place where, yeah, sure, it was an idea, it was technically possible, but now we're seeing it actually, we're seeing actual volume take off in these markets. And I think it's a super cool use case.
Interesting. Okay, so to ask more of a technical question now, surrounding AlgoKit.
Sure.
Last time we had spoken that people were actually using AlgoKit a year and a half ago, and they started to do stuff with it. Out of AlgoKit 2.0, can you build something like Lofty?
Absolutely. In fact, Lofty was built before AlgoKit came out. So
Or AlgoKit?
yeah. So those guys didn't have the benefit of using AlgoKit. And so, just to give your viewers a little bit of context, Algorand is a layer one blockchain. It's programmable. You can write smart contracts or apps for it. So in that sense, if you're familiar with Ethereum, it's not too dissimilar, similar kind of concepts. And for those people who haven't used blockchain before, you can think of them essentially, these blockchains like little operating systems, right? It's like Mac OS or Windows, except for rather than running just on your computer in front of you, they run on many computers around the world. And the reason why you'd want to build an app on a blockchain rather than say just writing the app for Microsoft Windows or for Apple's Mac OS is because the kinds of apps you can build on blockchain um, benefit from the virtues of blockchain, which are things like self-sovereignty or being permissionless or being censorship resistant, or maybe, the big one, which is running in a decentralized context, so running in many places at once, you can be assured that your app will execute with correctness. And so, if you have a Windows computer and you write an app for it and you've got a virus or you've got some malware, maybe your application stops behaving correctly. Maybe your web browser takes you to a site you don't want to go to, even though you didn't click it, right? The malware will change the behavior of the application. Well, on blockchain, when you build your app, it's immutable, and so the app always behaves the same way every time you run it, and that's ensured by all of the computers that are running on the blockchain at the same time, and that's the kind of value proposition. And so when I came to Algorand about 3 years ago, at that time, people were writing their apps in a language called Teal, which is like an acronym. It stands for like Transaction Execution and Approval Language. And it's like a very low level computer language, like talking to the ones and zeros and trying to get your computer to do what you want. And of course, modern applications, like an iPhone app that you use, like Instagram, is not written in some low level language. It's written in a simple, high level language, which is very easy to express your business intent. It's very easy to add new features. And so if you look at blockchains not as speculation platforms for tokens, but instead think of them more like an operating system, more like a computer, um, you'll start to get to the same place, which is that, hey, we should make it really easy for our developers to build apps on this platform. Otherwise, people are not going to bother. They're going to build somewhere else. And so the idea of AlgoKit was born, and AlgoKit is a tool to build applications on Algorand, and it gives you everything. Okay, it gives you tools for building, testing, deploying, enterprise grade stuff like CI/CD for folks who are familiar with that kind of stuff. So it's basically a tool set that is from very beginner hobbyist 16-year-old 15-year-old kids who are just exploring the idea of writing software for blockchains all the way to enterprise grade apps like Lofty. um, and so Lofty would have struggled through the years of Teal and things like that, and written their contracts and their apps in a very low level language. But with when AlgoKit came along, we finally had a command line tool that helped you, like I said, build, test, and deploy. With AlgoKit 2, we made a big leap and we brought Python to Algorand. And so you could now write your app in just using Python, the same Python that's used for generative AI, the same Python that's taught in high schools and universities around the world. Today, we have launched AlgoKit 3. And AlgoKit 3 is another quantum leap forward.
When was this?
Just this morning, actually, just
Just
this
this
morning.
morning, you know.
Yeah, yeah, just this morning. So like an hour ago.
Okay, so Algo 2 is out of the window now. It's now
Yeah,
Algo
yeah. Well, it's still
3.
there. We still have Python, but it's now with the new hot thing is AlgoKit number 3.
All right.
Um, and so AlgoKit 3 again, it's still just a tool, right? It's a box of tools to help you build apps, write them, test them, debug them, ship them out the door to your customers. That's all it is. But now we've added TypeScript. And so TypeScript, again, for people who are not coders out there, Python, very popular coding language, used all over the world. TypeScript is another software language, another programming language, I think started by Microsoft, which builds on JavaScript and tries to make JavaScript a bit more enhanced with a typing system. And you can now write apps in regular TypeScript. And by the way, this is really important. If you go to the Ethereum ecosystem and you say, how can I write an Ethereum app in Python? It'll tell you, hey, Viper is over there. They have a thing called Viper. You can write apps in Python. Wrong. It's not Python. It's Python-like. And if you type in Ethereum, how do I write an app in JavaScript? It'll say, oh, Solidity. Solidity is the language of Ethereum contracts. And it's like JavaScript. It's kind of like it, but it's not actual JavaScript. It's JavaScript-like. We made a design decision with AlgoKit 2 and most recently with AlgoKit 3, where we were insistent on bringing semantically and syntactically regular languages to Algorand. And what I mean by that is it's not Python-like, it's actual Python. Same rules, same words, same syntax, same way of doing things. It's not TypeScript-like, it's actual TypeScript. And again, same rules, same language, same syntax, same way of writing code. And so what does this mean? Well, it means that businesses out there can bring their products from an idea in a guy's head or a girl's head, a startup idea, all the way to production really fast, really cheap. And when they've launched their app, like Lofty have, maintenance of those contracts won't be really expensive because you don't need to hire a Solidity developer or a Move developer for SUI, or a Solana, someone who specializes in Rust. Okay, you can hire a Python developer or a TypeScript developer, which are some of the most common and easiest languages to understand and to write. So it doesn't cost a ton to hire developers for them. And then you can build your app using those tools. And maybe two other little things. Number one, we launched a wonderful visual debug tool. And so when you write code, you regularly have to find the bugs in your code. Okay, people are familiar with bugs in software, I think, at this point globally.
Bug bounties, no? As well.
Yeah, bug bounties, and I had one in YouTube the other day on my phone where it wouldn't play the videos in high quality anymore, and they fixed that. So software has bugs even when it's written by the best engineers in the world. And so how do those engineers fix those bugs? And the answer is a process called debugging, which is the idea of like removing bugs from your software. By the way, it was called a bug because originally in very early computers, an actual physical insect crawled inside one of the very early mechanical computers, causing it to malfunction. And they found this bug literally inside the mechanical computer back in the days of vacuum tube computers kind of thing. So we still call it bugs today. And so you need to debug your software. And so it's hard though with normal software. You kind of walk through it like that line by line, ba-bum, 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 ba-bum.
Yeah.
And so with Algorand and with other blockchains, it's like, well, how do you debug software that's running on a blockchain? It's a bit harder, a bit more different. It's a bit different. And so the approach we took is a visual one. We wanted people to be able to reach out and touch their transactions to understand how their code was interacting with the blockchain. And so now as part of AlgoKit 3, we have a visual debugging tool. And what this helps you do is when you interact with the blockchain, you literally see in a beautiful graphic how your code is interacting with the chain, and it really helps bring to life the process of debug. And then finally, we've also launched a radical new developer portal where anyone from a beginner to an expert can go and read about the developer process, understand the tools, and learn about AlgoKit and the Algorand platform. So yeah, a very exciting time.
So there's a lot of progress being made and quick, rapid progress.
Yeah.
Does Algo 3 have access to AI in any way?
So great question. Yes, so our developer portal will have an AI component where you can essentially ask it any question about the developer docs. And we specifically structured our developer documentation so that it would be ingestible by models that were trained on it. So we've kind of structured the developer documentation in a way that's very consumable or easily consumable by AI models. But maybe even more important than that, um, TypeScript and Python, because there are languages now, Python with AlgoKit 2, and then today TypeScript with AlgoKit 3. These are languages that AI models know. If you go to ChatGPT 4.0 or you're using Phi or you're using Gemma or you're using Quen, doesn't matter what AI model you're using out there, Grok, doesn't matter, Gemini,
You
they
know,
all know Python and they all know TypeScript. Now, they're okay at Move, they're okay at Solidity, but there's a bigger corpus of data out there in the world. And I say corpus, I mean collection of data that they're trained on from the worlds of Python and TypeScript, because they're the biggest languages in the world, and so there's the most information out there to train these models on those languages. And so, and again, because we critically made the decision to make it so that these languages were semantically and syntactically regular, they're not flavors of these languages, they're actually Python and TypeScript. You can essentially talk to any AI today, any AI model, any generative text model, and ask it questions about Python engineering or TypeScript engineering, and it will give you answers that are good in the context of an Algorand smart contract. So yeah, it's very much strategically aligned with generative AI. It was a little bit of luck, to be honest, because when we started doing this work, generative AI was not as popular as it is today. This is a few years ago that we've been working on this stuff. It's been in the kitchen for a while, but it was clear from the early days that this stuff was starting to take off, and so we started to align our strategic thinking.
So I've been reading about self-writing and how self-writing is like this new thing where you can go in and you can just basically say, listen, make me this website, make it accessible for payments and all this kind of stuff. And me as a non-developer, I can actually spit out, I don't know, a website out of this. Is this something that AlgoKit 3 can do, or is it something that sort of Algorand aspire to be at in the next year or something like that?
And so something like that. So I've heard this called vibe coding as well. I'm not sure if
Vibe
you've
coding, yes.
heard that expression. Yeah, yeah. I think it's cool, by the way. It's great to see people get involved. I mean, look, I'm not a chef, but I like to try to cook nice meals and stuff for my family or whatever, right? So it's like I think it's good to try to do things that are you're passionate about, but like don't have a lot of experience in. It's a great thing. Um, so that wouldn't live at the language level. So when we built Python and TypeScript implementations for Algorand, we built a compiler tool chain and all kinds of stuff to make that happen. And AlgoKit really is a collection of tools, right, inside a box. And so where that would live, the kind of thing you're talking about is in the integrated development environment. So you will open an app like Xcode on the Mac or VS Code on Windows or Linux or Mac OS, and VS Code, which is the same tool you use to write Algorand code, its its job is like to be the Microsoft Word of code, right? It's the application that you write the code inside. Now you're writing Python or you're writing TypeScript and you're compiling it with AlgoKit, but you're writing it inside VS Code, which is like I said, the Microsoft Word of code. And so that's where it's at the VS Code level that you'd have a generative AI tool that would help you vibe code. And so absolutely, it's possible to we have plugins for VS Code that help you do all sorts of things, and so they could be extended to help you vibe code your smart contracts 100%, no problems at all. I think that there is a little bit of danger, of course. I should just kind of voice it, and this is a personal view, but as cool as it is to kind of vibe code your way to something great, and I've seen some wonderful examples on X where people have created games, websites, like physics demonstrations, all kinds of cool things. Um, but when you're building blockchain apps, you're usually handling money, and it's really important to understand your code. I think because you want to make sure that like the code you're writing is valid and doesn't have any bugs. And so sometimes Gen AI can give you things that work, but maybe not be completely secure. And so just a kind of a not a warning, but just a note to people out there: if you're vibe coding your way to blockchain based apps, just try to make sure as best you can that you understand what comes out of the LLM before you launch it into production.
Yeah, because there's no expert on your site who's building it. You're taking responsibility for it. So make sure that
Right.
it's not too complex, basically.
Right, and if you're playing around, it doesn't matter, right? But I'm just saying, if you're
Yeah.
kind of going to launch Lofty 2 and you're handling millions of dollars of volume, it's important, I think, to understand the code, so that you can read through the code that comes out and you can say, hey, I understand why it's doing what it's doing here.
What's cool is these smart chain blockchains, they're starting to find niches, I'm seeing.
Yeah.
So does the Algo kit, so if we use AlgoKit 3, no matter what we build, does that become quantum resistant because it's built in the bubble of Algorand? And
Right.
how do we
Yeah.
secure these contracts?
Great question. So Algorand is not fully quantum secure yet.
No.
It has started this journey, and it's about a third of the way, approximately, to quantum security. And maybe I'll just talk a little bit about quantum and quantum security, and then I can talk about how your apps enjoy that protection on Algorand. So, in a 30-second soundbite, quantum computers are new types of computers that don't do everything, but basically do two things very well: factor numbers, and are able to search through large data sets. They use special physics, quantum superposition, and other kind of groovy, exotic physics like quantum mechanics, in order to basically do these computations incredibly fast. They don't really exist yet, right? They're theoretical. We've made some baby versions of them, so to prove that they can work, but we haven't got one that can attack blockchains yet. Some people think that this is going to come in the next kind of 5 to 10 years. Other people think 2 years. Other people think it'll never come. But I'm on the camp that thinks it's going to be pretty soon, because of the progress that's been made by companies like Google with Willow, if you want to Google that, or Microsoft with Majorana, if you want to Google that. So these large companies are building more and more powerful quantum computers all the time. Okay, so it got serious enough that the Americans, the let me just double check. I think I misquoted this last time. Yeah, it's the National Institute of Standards and Technology. I made a mistake the last time I quoted that. So NIST is a government body in the United States that sets standards around science and tech, and they were one of the front runners on standardizing cryptography that we use today for banks, online privacy, messaging apps, and blockchain. And so they came along a little while ago, a couple of years ago, and they said, "Hey, we're going to have a competition globally with all the super nerds, and we're going to try to find a new cryptography standard that is quantum secure." And I know these quantum computers don't exist yet, but pretend they do, and build a thing that they couldn't break. And so all the big brains got together and they came out with a bunch of different ways of doing this. And so the front runner, the one that's probably the most popular at the moment, is lattice-based crypto. So it doesn't use elliptic curves as Bitcoin and Algorand do, but it uses lattices to achieve its security. Okay, so that's quantum computing and where we're at. Now I'll talk about how Algorand has adopted some of this new groovy lattice crypto to be super secure against quantum computers. If you want to secure your blockchain against quantum computers at a high level, slicing and dicing this, roughly, because this is pretty high level stuff, right? You could do a PhD, I think, in this topic. You got to secure the history of the chain, so all the transactions that happened going back to Genesis, to the very first block. You got to not secondarily, but second, you got to secure the consensus mechanism. So that's like proof of work, proof of stake, how new blocks are mined, how new transactions are valid. You got to make sure that that's secure. And the last piece you got to make sure is bulletproof is accounts. So you have my public key, you have my receive address. Can you use a quantum computer to attack that and get my coins? Right. So they're the three areas. A quantum computer across the board, like broad stroke, can attack history of the chain, certainly for proof of stake systems, can attack the consensus mechanism. Okay, again, certainly for some proof of stake systems, and can certainly, across all cryptocurrencies, including Bitcoin, Monero, the whole lot, can attack the accounts, right? Can take public keys and reference.
It's quite scary.
Yeah, quite scary. Exactly.
It's aimed for 2035. This like.
Yeah. I mean, I think it'll be sooner, but I mean, I don't know, but I think my gut instinct is it's going to be sooner as someone who's looking at this stuff evolve. Anyway, we at Algorand have fixed problem number one. We've basically, the history of the chain is quantum secure, and how do we do that? Every every 100, sorry, every 256 rounds, so it's like, every 12 minutes or so, we sign the history of the chain with a quantum signature. And it's not like me or my colleagues or the foundation, it's the consensus mechanism itself. The protocol signs all the blocks in the history of the chain. And so if a quantum computer existed today, we couldn't go back and rewrite Algorand's history. We couldn't change that. But we could attack consensus, which is ongoing every single day, and we could attack accounts, which is like reversing the public key into the private key to get your coins. And so these are the two areas that we have to look at next. And so our focus is going to be accounts first, okay, because we think it's probably the right thing to do next. And then finally, we'll look at consensus. But Algorand is, it's this stuff is like super nerd stuff. Like you got to know math, cryptography, applied math, engineering, software. You need the intersection of a lot of different disciplines to roll something like this out to $1 billion network. And so I'm proud of the team because what they've done is they have taken the first step on this, right? They've brought to production in the real world on a real production system that's out there being used. They've brought post-quantum security to the history of the chain. And so we've learned a lot doing that. It wasn't easy, but we learned some lessons there. And so now when we're looking at the engineering around securing accounts on the protocol with a quantum resistant scheme or quantum secure cryptography, we're approaching it with a much more nuanced angle. And so my advice to kind of blockchains out there will be start looking at this stuff. You don't have to start writing the code, changing the code today, but understand where you're vulnerable. Try to understand what it would take to fix. And then I think most critically, try to understand the impact of the fix. Because if we add post-quantum security like gravy, we pour it all over accounts and like, oh, look at that juicy post-quantum security, it's great. What you'll find is transactions are bigger. So your blockchain gets fatter faster, right?
Why would transactions be bigger?
I'll tell you, because elliptic curves, the crypto that we use, say, today, the transactions are like, a signature is like 64 bytes, right? It's quite small. With like post-quantum cryptography, rather than 64 bytes, it might be like 64,000 bytes. And so, I mean, it depends on the scheme you use. Some of them are bigger or smaller, but it's thousands of bytes. It's kilobytes per signature. It's kilobytes for a public key rather than being, double-digit bytes. And so, just because of the complexity of the mathematics in these schemes, the signatures are bigger, the files are bigger, the transactions are bigger, and so, yeah. So all of a sudden, if you added this quantum stuff everywhere, things would get slower. The blockchain would get bigger faster. It wouldn't scale as well. And so, I guess my point is, it's not just a matter of just like changing. It's a matter of doing it in a way that's elegant, and that can be hard to do.
Does this then touch on Falcon signatures?
Right. Literally, yes. So Falcon signatures Falcon is an acronym. Okay, it stands for it's like fast Fourier lattice-based signatures over n-true. Let me actually look it up because okay, I want to, yeah. So it's no, it is that. Okay, so fast Fourier lattice-based compact signatures over n-true. That's what Falcon is. It's the F is the fast Fourier, and n at the end is n-true. And so Falcon is like a way to do digital signatures that are post-quantum secure. And that is the same technology that we've applied to the history of the chain. That is what we're using to secure the history of the chain against quantum attack. And we will probably use Falcon for accounts. So we'll probably make it so rather than doing an elliptic curve signature, like Bitcoin or Algorand uses now, we'll probably move that to be a Falcon signature for spending some funds. But we don't just want to make everyone use it because there might be accounts out there that only hold a couple of cents. And would it make sense for them to upgrade to their public keys? Probably not, because there's an operational cost to all this stuff. But if I was the Bitcoin in the Bitcoin community and I hold some small amount of Bitcoin, not a ton, but if I was a major holder in Bitcoin, I'd be looking at those Satoshi wallets and I'd be thinking, if they're not secured before quantum computers come out, the first thing a person with a quantum computer will do will just be move the Satoshi coins, and that's gonna have market implications, right? And how do you migrate his coins when the guy or the girl is not around anymore, right? The person Satoshi is not there to upgrade their account to this new scheme, right? So there's complexity, operational complexity in all of this.
That's very scary, actually. That's what you're saying. I had asked ChatGPT. I said, "Will they solve quantum computing?" And it said yes.
Yeah, yeah. And the thing is, right, and what are the challenges? Maybe we should look at the challenges. In order to build a quantum computer that can take a Bitcoin public key, which is in a Bitcoin transaction, right? When you spend Bitcoin, you reveal your public key. And actually with Algorand, the receive address in Algorand is literally the raw public key. So you don't even have to spend your algo to reveal the key. The public key, the receive address is the public key. So if someone had these public keys, they can just use a quantum computer to reverse them into the private key and then spend your coins. So there needs to be a process by which you can run the attack on these public keys. And so the process is you take someone's public key, you put it into the quantum computer, and you run an algorithm called Shor's algorithm, which is a guy called Peter Shor came up with it, but it's basically a mathematical approach to use a quantum computer with all the groovy things it can do in order
Different
to turn a
universes, no?
huh?
You take different universes, like.
Yeah, yeah. Well, I'm really, I suppose what's happening is you're performing like you're reversing the discrete log by performing parallel calculation of the discrete log with bits being in probabilities of superposition rather than being in multi-dimensional universe. But at the same time, it is like black magic. It's like voodoo. Okay.
Yeah.
And so, the thing is to do that algorithm, to run that algorithm, you need a fast quantum computer. It's a bit like when you were a kid and your computer wasn't fast enough to play like Doom or whatever, right? Or Quake. It's like you need a fast quantum computer to attack these modern cryptography schemes. And the ones produced by Google, Willow, the ones produced by Microsoft, Majorana, or whatever they're calling it, that I mentioned earlier, they have like a few qubits, right? A few logical qubits. You need thousands of logical qubits to attack these schemes. So we still have to grow these baby quantum computers by a factor of 100 or 1000 before they're dangerous. So just like but
Is it like the quantum computer, which is a threat? Is it like you're talking about the first mobile that came out? We're there kind of thing in the late 80s, where you had
right,
that big phone kind of thing. You can't do anything.
right.
But
Right, and actually, if you want to think about it like rather than mobile phones, because they got quite serious quite fast. But if you want to think about like computing, it's more like we're in the '60s, and we have like like one of those old computers that has the vacuum tubes in it and stuff like that, where you can add two numbers, but it takes like 4 seconds. It's like it's in that moment. We can basically build these things and get them to like do very basic computations and prove the idea works, but like they can't come close to breaking a Bitcoin public key at the moment. But the question is, and by the way, the major breakthrough of Google's Willow and Microsoft's Majorana, the major breakthrough of those technologies, the reason they were in the news was because they were doing quantum, but people had done that before. But the major breakthrough was they had found a way to scale it better. And so they still didn't scale it up to like one that's dangerous, but they found a way that it was going to be able to scale without getting shaky.
they
Because
found a lightning kind of thing.
right. And so it's like I like think of it like a Jenga tower, like the game Jenga. You build it
Jenga,
once,
yeah.
it gets wobbly, right? And so the problem was they were building bigger ones, but they were wobbling and falling over. These ones, as you build more, they get more stable, not more wobbly. And so but the thing is, it's not easy. It's still not easy, but
That's interesting, basically, to the
yeah,
whole way. That's
yeah.
interesting, basically, the whole way.
So, I mean, will we be in a world where we have these things, like a quantum computer soon? I think sooner rather than later. I mean, sure, it could be 15 years away, but I think it's going to be more like 5. I mean, look at the speed of innovation that we're seeing.
Yeah, for sure. And the thing is, I was reading about this, not to spend too much time on this, but
Yeah, sure.
but the argument is that, like, okay, let's say quantum computers now exist. It's 2036, 37, 35.
Sure.
They can actually hack anyone, not just a Bitcoin. But would they go for Satoshi's coins as a statement? Like, what do you think?
Right, they can hack anyone. Who will be the target? Who will be the
I
first
mean,
target?
no, they can hack a bank account, they can
Right, right.
hack anyone.
I mean, probably
Can hack
not.
the euros in your account or the USD in your account. So why
Right.
uh,
Or listen to your conversations maybe on Signal or whatever, right?
yeah,
Right. So you're right. I think in the initial term, like when these things first come out, it won't be. They're not going to be going after my algo or your Bitcoin.
exactly.
It'll be much more likely that it's some Mossad or some like I don't know some state level espionage.
Yeah.
But it's not about that for me. It's not about me personally being attacked or you being attacked or Satoshi being attacked. It's rather knowing that it's insecure. And the moment that we know as a community, I say a Web3 community or even a cybersecurity community or computer geek community, the moment we know, oh shit, this stuff is broken, I think that's the moment we see some serious turbulence in the market. I mean, before anything's stolen, it's like that's when the panic sets in.
What are the odds of this? What are the odds of it being broken?
Oh, like it's
Like a
certain.
percentage. Like what's the first number that came to your head?
As in, like, if the question is, what are the odds of breaking a public key if we have a functional quantum computer with enough qubits? The answer is 100%. It's possible. Like,
But
it,
what are
it
the odds that we'll build a wall that they won't be able to breach, let's say?
oh, I think like 85%,
That's it.
90%.
That's
Yeah, yeah.
it.
Like, we don't know for sure that these schemes work because we haven't attacked them with quantum computers yet, but we are mathematically assured that like this post-quantum cryptography works. And there's not just one. It's not just like Falcon is one. So Falcon is one type within the family of lattice-based crypto. But we don't just have that. There's many others in the lattice-based family, and there's also other families of math that we can use against quantum computers. So there's like multivariate, hash-based, code-based, super singular, isogeny-based, and so we have many options. The question is, does your blockchain of choice have the intelligence and the capability to implement this in a reasonable time frame? Now, I personally think Bitcoin's got too many smart people working on it to worry. I think it'll be okay. I also think the same of Ethereum, okay, because I think they've got too many smart people who want to see it succeed, and I think they'll be fine. And by the way, I should also say, not all blockchains are vulnerable the same way. Some are more vulnerable than others. Blah blah blah. It's quite complex. You'd have to look at the entire technology stack. But all modern blockchains, certainly in the top 100 that I've seen, have fundamental flaws that in their current form would be eviscerated by a quantum computer, including Algorand, by the way. Not the history of our chain, but certainly the accounts
Yeah.
and the consensus. Yeah.
It sounds like quantum computing can be the next nuclear bomb. Everyone has
Right.
their own, everyone has their own, and it's like, hey, don't screw this up, don't screw this up. And like we might have to juggle that a little bit.
Yeah, sure. I totally agree. And here's maybe the interesting thing for me as well is like sometimes I feel to myself, Jesus, would you not just stop working on this stuff? It's like a pain in our ass. Like, why do we want to do this to ourselves? But I guess a bit like the like a nuclear engineering or whatever, it's like humans will smash forward into new technologies. I suppose that's what separated us from animals when we were like cavemen or whatever, making the wheel or fire or other things. And so it's in our spirit to innovate. And so I think you can't discourage this. I think we're always going to try to break things and find new ways. But we have to also equally then try to secure ourselves against these innovations.
Yeah. Nicely put. So to shift a little bit, are you seeing institutional players coming around asking questions?
Absolutely. And by the way, not just institutional players, but also nation
Countries,
states.
maybe?
So like, in the Middle East, the UAE very interested in this. They're currently working on basically a blockchain advisory group. They've got a whole bunch of stuff going on with Hub 71 around tokenization. You've seen in the US, of course, the administrative the vibe change with Trump and the rest of the guys over there in the administration. They're much more pro crypto. Um, and also, yes, institutional players are very much interested in this. Whether that's like I won't be able to name names because, of course, it wouldn't be appropriate. But like whether that's household kind of hedge funds and money markets, all the way down to brand names that you would have heard of that are like car
Interesting.
manufacturers or whatever.
Tell me more, kind of thing.
Yeah, people don't like companies don't want to be left behind. And if there's a way that they can execute operationally with a reduced cost, they will take that. And if there's a way that they can provide a service to their customers that benefits the customers in a way that they will garner more revenue, they will take that too. And so these blockchains are not some kind of silver bullet or special panacea here. They're not going to like revolutionize how you drive your car, but they might add features to an existing technology stack which are compelling for customers, and once they hit that point, they become these companies have a focus on them.
Exactly. I was listening to Stacy
Sure.
Woodin speak, who's the CEO of
Yes.
Algorand.
Yeah, my boss, Stacey. Yeah.
And I'm just remembering now, which like I'm thinking to ask. I think she mentioned a situation where Algorand is building towards having a wallet that you can have your algo on it and you can spend at shops and buy stuff. Is that actually happening, or did I understand correctly?
Absolutely, it's happening. So we have an integration with MasterCard now in our Para wallet. So Para is like the MetaMask of Algorand, except for it doesn't run in a browser. It's not a browser extension wallet. It's a mobile wallet for iOS and Android.
Virtual card, what? Or
Yep. And you issue a virtual card right there, like a virtual MasterCard. It's a fully branded regular MasterCard. We're going to be launching imminently. So
Amazing.
I have a test version of this thing though because I'm the CTO,
Nice.
so I get to test it. And so the other day I was in a pub, in like a public house, which is a place that sells food and alcohol in Dublin. And I had so Algorand has staking now, so you earn staking rewards for staking your algo. And so I'd accumulated, I don't know, $16 worth of staking rewards over a few days. And I converted them. I converted the algo into USD. Okay, so USDC token, right, in my Para wallet. And my Para wallet was one of the beta Para wallets that has this integration with MasterCard. I had a virtual MasterCard, just like Revolut or Monzo or one of those. Could see on the screen the virtual MasterCard. And I was able, the waitress came over, and when I was paying for my sandwich and soup, I was able to basically tap my Para wallet, and it paid right there the virtual MasterCard directly in the terminal. And it was the first time I'd used it, and I was like waiting to see what her reaction would be, to see if she's seen anything weird or anything. And she was just like, "Okay, cool, thanks." And she walked away.
And
And it
your
was like,
algo was spent
right,
on
so right,
USD.
so I tapped my Para and wallet, and for her, that was just a normal transaction on the terminal. She walked
Yeah.
away, wireless terminal, walked away. But for me, I had used algo that I'd earned using my from my staking rewards. So I'd earned algo from proof of stake staking algo. It got converted into USDC. Okay, so dollar tokens. Those dollar tokens were loaded into the
You did
MasterCard.
that, or it did that as you were paying.
It
As
did
you were
that
paying.
in one fell swoop, yeah. And then basically it forex the dollars into euro, because I live in Ireland. There's euro there, and yeah, there was a charge on that, like 1.5% or something. It wasn't for free, of course, but normally I wouldn't use dollars if I didn't have to. But my point is seamless end to end,
Seamless.
right? Yeah,
Amazing.
it's awesome. And so rolling this out though to a small group of users like myself is one thing. When you roll it out to the community, you have to have support. You have to have, oh, my transaction failed and now but the money's not in my account. You need someone to talk to on a phone or whatever. And so the last step before we kind of roll this out publicly is to make sure that those infrastructure items are in place. We need to make sure that that's all that all of those kind of things are ready to rock and roll, and so that the end user has a great experience.
Yeah, exactly.
But like from a technical point of view, it's ready to go.
You think this will come out 2025?
Oh yes, 100%.
Yeah,
Yeah, 100%.
That's really good, because
Yeah,
now people can actually hold and spend.
right, and so, totally. And by the way, I've got colleagues of mine who are using this on a daily basis. And we didn't have to work directly with MasterCard ourselves. We went through a company called Immersive. They're a partner that basically handled the relationship with MasterCard, but it's great. We issue, and by the way, these are regular MasterCards. They're not like weird ones or fake ones. They're real MasterCards.
Interesting.
Yeah.
So to conclude, I wanted to ask, I also saw that Algorand got Mark Van Leberg,
Oh, yes.
and he was responsible for the Android in Google. So obviously
Right.
you're pulling in a lot of talent.
Yes.
So how do you see the Algorand team growing into 2025 and beyond?
Sure. So I think,
And as a last one, where do you see the crypto market today and in like 5 years time or a year's time? Let's say a
yeah,
year.
sure. Yeah, I can answer all of that. And again, maybe I'll start with the crypto market. I think that it's, of course, I don't know the future, and I could be completely wrong here, but my personal guess, without naming any particular cryptocurrency, if I look at the global market capitalization of all crypto, I think it's about 2.7 or $3 trillion. Let me just actually see what it is right now.
Almost four it was in
Oh,
January.
yeah. Yeah, so it's 2.8 right now. So
2.8 now
yeah,
three.
according to CoinMarketCap. If you compare that to the market capitalization of other major verticals like precious metals, where gold or silver has, I don't know, 6, 8, 12, $14 trillion valuations. Yep.
22 together. So gold is 20 at the moment, and
It's
like
20 at the moment?
I think it's 20 at the moment. We can check,
Wow.
but silver is 1.8.
Okay. So
So
there you go.
yeah,
Right. So you're talking about like 5x what crypto currently is, right? For just gold alone.
20 it is. I just checked. Yeah.
Yeah. Okay. So look at that. Okay. Good info, because I hadn't, the last time I looked at that was about 10 years ago. Okay. Great. So you got gold. It's no longer 12 trillion. It's now $20 trillion, right? Crypto 2.2, two and a half. I mean, for me, crypto by definition has to have a market capitalization somewhere around what gold has. I mean, it's essentially a more modern form of that asset. It's a hard, tangible asset, which is inforgeable, but is also infinitely divisible, essentially, and is easy to carry. And so, I mean, I would say that if you look at the value proposition of crypto, the idea of censorship resistance, being permissionless, being decentralized, being hyper secure, in many cases being deflationary, being a hard form of money, being digitally native, internet native, able to integrate with agentic AI seamlessly, essentially being the best form of money humans have ever invented. Um, and being like, you don't, if you want to bring your gold from one country to another, you gotta get a cargo plane. You can walk around with $10 million of Bitcoin by memorizing a sentence. um and so it's hard for me to see a world where crypto doesn't end up being worth a gold level market cap. Okay, so I suspect somewhere between 10 and $20 trillion makes sense for crypto. And so that necessitates a market movement much higher than we are today. But of course, I don't know. But I would say, so we could see crypto go way lower, of course. But my personal instinct is that we will see crypto increase in value dramatically from where it is today. Which coins go up and down, I don't know. Some may die, some may do very well. But I think as an asset class and as an industry, I think it'll do very well over time. Is my assessment. And yeah, just to touch back on Mark. Mark joined us from Google. He famously had worked on the Android KitKat. I'm kind of dating myself there, but there was a version of Android called KitKat a long time ago, and he did the marketing around that, and it was very successful because they actually co-marketed with Nestle's actual Kit Kat confectionery chocolate bar. And so he's an incredibly experienced executive in marketing. He's very creative, very dynamic, and it's wonderful to have folks like Mark on the team. And I think very much in the crypto space, like, the game is a tech and marketing game. It's like the narrative, what's the vibe, and
Tech and
also
marketing. It's
how
true. When you say it
right.
like that, it is
Yeah.
tech and marketing. It's
It
true.
is. It's like 50-50. You can have great tech, and if you've got shit marketing, you lose. If you've got great marketing, but your tech is terrible, you're still going to lose. You need both. They're both very much part of the story. And so having Mark on the team is wonderful. I'm not saying our tech is perfect, but we have, I think, strong tech. And when you have strong marketing too, you have the winning formulation. I think I would like to also see, to maybe give a slightly more substantive answer around where we want to grow. I'd like to see more decentralized engineering of the protocol. So right now, Algorand Technologies engineers the protocol directly. They've done an exceptionally good job. They're very talented engineers, but we need to move to a place that's a bit more like Monero or Bitcoin, where it's community-led engineering, because that's the only way to be sustainable over very long periods of time.
In, could you repeat that last bit? That last
Yeah, sure. So my point is,
because you made me think of
yeah.
Mimblewimble in Litecoin.
Oh
Because
yes, yeah.
they have Mimblewimble where you don't see
Sure.
I think
Okay.
something that is like Monero, so I'm assuming Algorand wants that as well. Just that's what I
Oh
might.
yeah, privacy is very important. And by the way, privacy is part of the things we want to do in 2025, including private token transfers. But I guess speaking more largely about areas we need to grow beyond post-quantum security or privacy, like Mimblewimble and technologies like that, um, I think it's critical to take a decentralized ethos with regard to the engineering of the protocol itself. So rather than be one company like a technology company or a devco that works solely on the protocol, that the protocol is engineered by the community, like Linux or Bitcoin or Monero is they're three good examples, I think, of open source engineering. And so there's open source where you review where you have the code is open for anyone to read, but there's also open source where anyone can write the code. And we need to get to that place for real sustainability, I think.
Cool, cool, very cool. Okay, I've asked all my questions. Just one came up to my head because I know that America is doing this digital asset pool of whatever,
Yeah.
and I had read like Algorand is being recognized as an American blockchain.
Yes.
So if they come out with like anything you make of crypto capital gains, you don't have to pay. Algorand's one of those. Um, but is there more to it? Like, is there more to it under the hood?
So Algorand is fully engineered in the United States and it's headquartered in Boston. And so it is absolutely true that Algorand is American made. As to what the classification will be by the US government, we don't have clarity yet.
You know that, yeah.
Yeah. But like our expectation is that we're part of that cohort because it quite literally has been built by Sylvia McCallie and Algorand Technologies in the United States. Yeah.
Really cool.
Yeah.
All right. Thank you for this update. A lot of stuff has happened, I think, with regards to Algorand moving in the last year only, because it's been only a year, I think, since I spoke to you last.
Yes.
So thank you very much.
Absolutely.
Yeah, and I appreciate the time.
Anytime. Great to talk to you, Andrew.